Hi, my name is Cameron Muckley, and this is my demonstration of tick-based servers for assignment 1. So tick-based servers are a large part of modern-day client-server gaming, and there are 4 key components that I'd like to bring up, being ticks, refresh rate, latency, and interpolation. So tick rate is the amount of times that a server updates the game's state, and when you perform an action, it is queued and resolved in the next available tick. However, in client-server gaming, the server holds the true state of the game, and 2 impacting factors for the client is latency and refresh rate. So latency is the length of time for packets to be sent from client to server and back to the client again. So a large ping, so like measured in ms, will mean that your actions and game state are delayed, commonly referred to as lag. And refresh rate similarly is client-side updates, which have been rendered by your video card and have been displayed on your monitor. And interpolation is something that I'll go a bit more into once I've kind of explained my demonstration. So I have made an implementation of how a tick-based server could kind of work, except this is all kind of client-side, so it's not exactly correct. So basically I have made kind of like a Clash of Clans type game where buildings are created on click. Now I haven't got the mouse position perfect and they just are generated randomly when you click on the screen, but this is on a tick kind of update server. So basically how I've done it is I have this C# code called tick system, and so in tick system I've defined tick timer. And so tick timer is the amount of time in between each system tick, and I've set that to be 0.6 seconds. When tick system is initialized, it sets the system tick to be 0, and it will, on update, check that the amount of time that is passed is equal to or greater than the amount of time I've defined in tick timer, and if it is, it increments the tick. And when the tick is incremented, it sends out a event which my other classes respond to. So this is the building class, and the building class has 6 images stored, and so these here are the 6 stages of the building. And in the code, every single time that a tick is sent out, while the building is in construction, it will increment the building tick, and it will assign the sprite that is currently up to in the stage of development defined in build tick. In game handler, it is mainly just checking for inputs through the mouse to define the creation of a new building, and on initialization just sets one to be in the middle of the screen. So even though I did kind of show it at the start, if I click play, as you can see, the current tick that the game is on is displayed within the console, and this is shown in this line of code here. So it checks and displays the tick that the event is currently on. And the other thing is that when you do generate a new building, you can see that even though it is responding to these events, it does appear to be quite choppy, and it might not be ideal when you go into other games. So this is where interpolation comes in, and so interpolation smoothens the movement of objects within the game. And so since the game is purely updating on each tick, it can appear to be clunky. And so while the server would be storing the state in ticks, interpolation is used purely client-side to make the game appear to be running a lot smoother. So in a game such as like CSGO, the position would be stored in the tick, so 64 or 128 tick, but interpolation would be used to make the player appear like them and like the enemies are running and like moving quite smooth. So this GIF that I found kind of perfectly explains how these things impact gameplay. So in a perfect world scenario where it was the true game state, everything would be registered and be quite crisp and clean as shown by the hit detection, but as it's not like that, often in games like CSGO, you could take a peek, or you could think you're safely behind something, or you could shoot, and you might have been shooting them on your monitor, but due to the actual game state, you end up missing your shots and getting really angry. And that pretty much covers everything I wanted to go over, so that was my demonstration on tick-based servers.